Hello, I will show you how to implement the n-queens problem in minicp in just a few lines of code. So, the n-queens problem, you probably know it. It's the problem that consists in deciding where you place 6 queens on a 6x6 chessboard so that they do not attack each other. And you have one such solution that is represented here. So, the way we solve this problem in minicp, you first need to declare a solver. This is the object that will be in charge of dealing with all the propagation and will also be able to collect all the variables in the domain. You have a factory method for declaring the solver like this. And then you also need decision variables. And for the decision variables, as you can see on the picture, we have introduced one variable for each row. And that variable will represent the position, the column position of each of the queen. So I declare an array of variables q, and I use again my factory for that. And I say that I want to declare n variables with domains from 0 to n minus 1. Okay? And the domain is really the flexibility that you have for the decision variables. And so if I need to represent it here, the domain would be from 0 to 5, you see? So 0 to 5, this is the domain. All the possible positions for every of the queens. And so the variable q0 is taking here in this solution the value 4. Then you need to enforce the rules, the properties of the solution that you want to discover. And for that, I will introduce a double for loop like this from I to n. And then my internal loop will again be until n, but I will start it in I plus 1 to enumerate every pair of variables. And I will add a constraint to my model. And adding the constraint to my model is using the post method. So I will post a constraint to my model. This is the language that we use in constraint programming. It's posting a constraint to the model. And you will use again the factory method to create the constraint like this. And you say that the queen I must take a value different from the queen j. If you do this, the solution that you will remove, for instance, is this one. You will say, okay, you see that these two queens are not, they are on the same column. This is forbidden. And this is what you will remove with this constraint. But you also need to enforce the rule of the diagonals. If you do this, the solution that you will remove is, for instance, this one. Okay, you will say that the red position is forbidden with respect to that one. And you also need to enforce the right diagonal, like this. So I will simply copy-paste this line, because the only thing that is changing is this. Okay, and so now you will, for instance, prevent this alignment between the queen 0 and the queen number 3. This is the right diagonal. So that's it for the constraints of my problem. Then you need to search for the solution. So there is a modeling part. This is declaring the variables and the constraint. And then there is a search part in a CP model. And so I will create a depth first search. Like this. And there is an easy branching scheme that is the first fail. And I can already declare this first fail branching scheme on the variables q. And so this will really explore a search tree for me that will try to discover what are the assignment of the variables that will satisfy all the constraints. Once you have done this, you can start the search and solve by looking for every possible solutions in your problem. And you can also collect some statistics. Okay, this is the result of the search. And you can print these statistics. That's it. And now let's run this model to see what happens. You can see here that the search has discovered 4 different solutions for the 6 queens problem. If you are curious to discover what the solutions are, what you can do is plug here a callback here on the depth first search. That will be called, notified, whenever a solution is found. Like this. And I can, for instance, decide to print the array of decision variables Q. Okay. And so normally this code will be executed for every possible 4 solutions that will be discovered. So every time a solution is found, it will print it. And that's it. You see that I have here my 4 solutions that are represented here and there.